On to exercise number 4. So you can see from the last exercise we got very good percent difference, 0.340 Newton meters and 0.337. So again, from our point of view, looking at it from this direction, the masses that are on the left-hand side are cause counterclockwise rotation and thus produce a positive torque. The masses of whatever we hang from the right-hand side, in this case, it was just the meter stick hanging at 50 centimeters. That would be negative torques, or clockwise torques. Now, exercise number 4, you can see we want to add another mass to the right end. And we're going to put it at 5 centimeters at the end, and then we're going to add mass until, not add mass, but we're going to move the meter stick until it balances. So in this case, we want to put 200 grams on here. So I've already got 50 on here. I'm going to put 100, and then, oh boy, I don't have a 50. I'm going to have to, let's see, this is, so I've got two 20s. I can't find 150, so we're going to have to put 2 5s on there. There. So I've got my 200 grams here, but this hanger also has a mass. So I'm going to have to, again, turn on my scale, my digital scale, and mass. So here's the 200 grams, and it's close. But I also have to add the mass hanger. So for exercise 4, the mass hanging from the right side is 223.0 grams. Now remember, the mass on the left side did not change from the previous exercise. It's still 121.8 grams. So you've got 121.8 still at 5 centimeters. And I'm going to put 223 grams at 95 centimeters. So I'm going to put basically the mass I just measured at the very end of the right hand stick, 5 centimeters from the end, which is at the 95 mark. So I'm doing that right now. I'm putting 95, I'm putting the 200 right there, and of course the meter stick now goes the other direction. This is going to be a heavier mass than this, and the meter stick is also actually not at its center of mass. So how am I going to balance it? Both of them are equidistant from the 50 centimeter mark, but one is twice as massive as the other one. So let's move the meter stick around until it gets balanced. So to do that, since there's a heavier mass, this came off here. I have to move it over, oh, almost. Nope, more. I'm actually going to lift this up a little bit more because these things are there. That's much more obvious now if it balances. I'm really close. You see how it's off the ground? Both of them are hanging off the ground. So in fact, I think I found my spot. I'm going to go and screw it in. So that's going to be my fulcrum where they balance out. So again, like in exercise number 3, you want to make another picture. So draw your meter stick. In this case, the fulcrum is now at 58 point, let's go a little closer to see if we can, let's see, 58 point, let me move down a little bit. You can see those, you can't see the ticks. Well, it's hard. Unfortunately, this meter stick got a little worn off. I can barely see the ticks on there. It's 1, 2, 3. I would say it's 58.3 is where the fulcrum is at. So 58.3, put the fulcrum there. Now, we've got the 223 gram mass right at 95. You see it's at 95? So on your drawing, put 95 on the meter stick, and near the right end of the stick is 95 centimeters. Again, put the mass, which is 223.0, and then we're going to find the weight of that in a little bit. Then, of course, the left-hand side hasn't changed. It's still at 5 centimeters, and I have the same mass I did before, so that's 121.8. Now, the only other thing I have to put on it, of course, is where the center of mass of the meter stick is. Remember, the meter stick is still acting as if all of the mass is at 50 centimeters. So to the left of 58.3, remember this was at 58.3, to the left of it on your diagram, put a tick at 50 centimeters and put the weight of the meter stick there. Remember, the weight of the meter stick is 2.045 newtons. So the entire weight of the meter stick is acting as if it's at that point right there. So to find the torque of the meter stick, you can see it's on the left-hand side. It's on the left-hand side of the fulcrum, okay? That means it contributes to the left-hand side torques or the positive torques, because these torques on the left-hand side are going to make the meter stick go counterclockwise, so they're positive torques. There's only one torque on the right-hand side, and that's due to the 223 gram mass. So let's go ahead and calculate those things out to see how good we did this time. Oh. All right, why isn't it? Hold on. There we go. I'm sorry about that. It just sometimes gets out of whack. So here's my picture of a meter stick. The fulcrum is 58.3. I've got 233 grams at 95 centimeters. Now, how much is the force? Because remember, torque is force times distance, so 9.95 centimeters is 95 centimeters is 0.950. There's actually 0 on there. 95.0 centimeters is 0.950 meters, and 223 grams. To find the weight, you have to take 0.223, right, times 9.8, and I get 2.18, 2.1. Let's see. Should I go with another? I guess it's okay to go 4, because I have 4 significant figures here. So I've got the weight, and I've got that distance. However, that's not the distance to use the torque. Remember, I have to use the distance between this, where the weight is applied, and the fulcrum. So I can't take 0.95 times 2.18. That would be incorrect. It's force times the lever arm. The lever arm is the distance between the fulcrum and where the force is applied. The same thing for these two. So I already know the weight of this one. Let's just find this weight really quick. This is at 0.05 meters. So 121.8 grams, 0.1218 times 9.8. I got 1.193 actually newtons. So this is the weight that's acting at the 5 centimeter mark. Now, what we have to do is figure out how far it acts from the fulcrum. So the fulcrum is 58.3. There's going to be 2 torques on the left-hand side and 1 torque on the right. So let's figure out the torques on the left-hand side first, which are the positive torques. So this torque would be 1.93 newtons times the distance between this point and this point. 58.3 minus 5, and what do you get? I mean, you could do that in your head, right? 0.533. So the torque here equals 0.533 meters. So it's 58.3 minus 5, 0.533 meters times 1.193 newtons. So this torque, I call it torque number 1 on the left-hand side, 0.533 times 1.193. I got 0.636, right? There's 3 significant digits here, so I'm going to cap it at 3. And again, newton meters. So that's one of the torques. But there's also another torque due to the meter stick. So we have to add to this torque the torque due to the meter stick. Now, how far away is this torque, this mass from the axis of rotation, or the fulcrum? 58.3 minus 50. So this torque, I'm going to call it torque 2, is I gotta change it to meters, right? 0.083 meters. 58.3 minus 50. So it's a distance of 8.3 centimeters or 0.083 meters. Then multiply it by 2.045 newtons. So what is this torque equal to? 0.083 times 2.045, the way of the meter stick, 0.1697, so 0.170. Again, we have to cap it to 3 significant digits. This is 4, but this is capped to 3, so 0.170 Newton meters. So the total torque on the left-hand side is what? You add them together. So you've got 0.636, you add to 0.170, and you should get a certain amount. I'm going to let you guys do that. I'm going to not do anything yourself. The only other thing we have to do is the right-hand side. So the torque you get over here by adding these two together. So what do you get? Like a 0.8 something, right? You have to use a calculator to find the exact amount. We already find the weight of this. The only thing you have to do is find the distance between this position and the fulcrum. Again, what do? You take 95 minus 58.3. So it's 0.367, 36.7 centimeters, right? So to find the torque on the right-hand side, that would be 0.367 meters times 2.185, and you get your torque on the right-hand side. Again, it should be really close to 0.367 times. Right. I get 0.8018. Now again, this is negative torque, so technically you can put the negative sign, but we're just looking at magnitudes right now, so you don't have to worry about pluses or minuses. This it actually is negative, so if you add this to the other torques, you get 0, because this is a negative torque. This should be equal and opposite to the torque on this side, which is, of course, adding 0.636 plus the 0.17, and you should see very close. Okay, so let's go on to the next exercise, which is another class. Oh, I know what we're going to do. We're going to actually create a balance in the next exercise.